Okay, I think we're just about ready to get started here. What iPad software do I use? I use what is it called? Good Notes. This is it here. Can I? Oh yeah, you can't see that. Here, I'll just bring it up on the App Store. Good Notes. It's a great program. I think it's $10. Good Notes. Yeah, Good Notes 5. This is the app that I use. It works really well. I love using it. Here, I'll just show you the whole screen. So mirror entire screen. Can you see that now? I think you should be able to see that. Yeah. Here, let me get this out of the way. Yeah, so this is Good Notes. It's really great. I love using it. You can choose all sorts of different colors. Also, when you have it hooked up to like a projector, or in this case on YouTube, I can click this button, and then I can have it mirror only the page. So now all you see is the important stuff, and then all the tools are only visible on my screen. So yeah, if your dad wants to reach out to me, I can tell him all about the software that I use. Also, I know that there's another program too that I've never used, but other people swear by it, called Notability. This one is also apparently very good. I know that people either use one or the other. I know that in the iPad subreddit that I follow, people are kind of loyal to one or the other, and there's a lot of divisiveness of which one is best. But anyway, we'll get started now. I want to talk about something that we haven't had a chance to talk about quite yet, and it's really just some terminology. I want to talk about the roots. Oops, that's too big. I want to talk about the roots of a polynomial. Polynomial. Okay, so we're going to talk about the roots of a polynomial. So we've looked at what polynomials are. So recall a polynomial. Has the form. It looks something like this. We've got a x to the n plus let's not make it too complicated. Let's just say it's like ax cubed plus bx squared plus cx plus d, or something that looks like that, right? We've got a variable with some exponents on it and some coefficients on those variables. This is what a polynomial looks like. The root of a polynomial, the root, or I should say a root rather, because there may be several. So a root of a polynomial, has the form, or I shouldn't say has the form, I'll say, so a root of a polynomial is a value such that when x takes on that value, the polynomial is evaluated as 0. Okay? So in a lot of ways, we're actually really familiar with roots of a polynomial. Just really quickly, let's head over to Desmos and take a look at some polynomials. I'm gonna plug my keyboard into my iPad really quick so I can type away. Okay. So let's talk about how do I hide this? I guess we'll just have to live with it. Okay, so let's talk about the polynomial. I'm just going to pull out some kind of random looking polynomial. Let's do 5x squared plus 3x. No, let's actually go all the way up to like the fourth power, just for fun. So I've got 5x4 plus 3x cubed minus 8x squared plus 2x, and let's do plus 1. Okay, actually no, let's make it plus 0.5. No, 1. Okay. I just chose some of those later values just so we could really take a look at some of the roots. So the roots of this polynomial, so this is a polynomial. It is a degree 4 polynomial because the highest exponent is 4. We'll go back to the notes in just a sec, so don't worry about that. I'll give you a chance to catch up in a second. So the roots of the polynomial are all of these points. So the roots of the polynomial are, negative 1.686, negative 0.043, 0.364, and 0.764. So those are all the roots of this polynomial. So it's values that you could plug into x, into the polynomial, and then you would get 0 back, okay? So I'll give you just a chance to sort of absorb these notes, and then we'll carry on. I missed the part about the polynomial. Okay, let's carry on. So what does this mean for quadratics? So in the world of quadratics, we have seen roots already. These are, well, on the one hand, they are the X-Intercepts. X-Intercepts of, they're the X-Intercepts of a quadratic function. Okay, and they are also the solution to a quadratic equation. Okay, so and those are two things that we've actually already done. We've looked at the x-intercepts of a quadratic function, and we've looked at solutions to quadratic functions. So in a lot of ways, we actually already know what we're doing with roots of some polynomials. So we're gonna keep up with this, and let's see what comes next. So so how do we calculate these roots? So how to calculate roots of a quadratic polynomial. Okay, well there's several different ways. One way would be to graph the polynomial. Okay, so we could graph the polynomial and observe the x-intercepts. Okay, so that's kind of what we did in Desmos here, right? So sorry if you're writing this down, but if I had 2x squared minus 6 or something like that, right? Then you could just take a look. Oh, there are the roots right there. So there's one, and then you'd be done. So that's one way you could do it. You could just graph it and observe the x-intercept. It wouldn't be too hard to do. Another way would be to write the quadratic expression as an equation set to 0, then factor, right? And then using that fact that, if a times b equals 0, then a equals 0 or b equals 0, right? That sort of thing. So you could factor it and find the roots that way. And then one last way that you could do it is you could say, okay, well, we could complete the square. We could complete the square, and then just solve. Come on, there we go. Then solve for x, and that's what we were doing yesterday. So we've kind of done all of these things already. But what I want to take a look at today is how many roots there can possibly be in a quadratic expression. Oh, you guys can't see that because my head is in the way. There you go. Okay. So yeah, we're gonna look at something a little bit different today. So what I want to like the question that I really want to investigate today is, how do you know how many? So how do you know how many roots we have? Okay, because I think it's fairly plain to see. Well, maybe it's not plain to see, but if I draw a couple pictures, it'll be plain to see. So so there's basically three situations that we can have with our quadratic equations if we graph them. So using this sort of the graphing model of roots, you could see that you could have either, well, in this case, with this parabola, we would have two roots. So we have two roots here. You could have exactly one root, like this, where the parabola sort of just grazes the x-axis. Or, you can probably see where this is going now, you could have no roots. So let me just make that clear. So the first one has two roots, this one has one root, and this one has no roots. Okay, so we have no roots. Oh, and again, you guys can't see that. So so that's what we're going to look at today. So how do we know how many roots we have? Like what's our strategy here? We're going to also take a little look at complex numbers. I mean, we're not going to do a big deep dive into complex numbers, but we'll see how they're quite relevant in this. So yeah, that's what our plan for today is. To answer all of this, to answer this big question, we have a beautiful formula that you may have heard of already. It's called the quadratic formula, and it's called the quadratic formula obviously because it deals with quadratic functions. So let's see if we can derive it. So and again, in class, like if we were actually in a physical classroom, this is the sort of thing that I would really want you to try to figure out for yourself, because you do actually have the tools to figure this out on your own. So in a sense, it's kind of a shame that I have to just do all the work for you, because it's actually really fun and quite satisfying to derive this yourself. But anyways, I'll just do it for you. So let's take a look at what the quadratic formula is. So the quadratic formula . Okay, so this is a quadratic formula. So what the quadratic formula is, I'll sort of describe what it is, and then we'll actually jump into deriving it. So the quadratic formula says, okay, so if you're given a polynomial, let's call it a polynomial equation of the form ax squared plus bx plus c equals 0. Okay, and I should say this polynomial equation is actually a quadratic, right? Because our exponent is 2 here. In any case, we could still describe it as a polynomial equation. This is absolutely a polynomial equation. It's just a special type of polynomial equation that is a quadratic equation, right? Because a quadratic equation is a polynomial equation. Anyway, so let's say that we're given this. The quadratic formula says we can solve for x in terms of a, b, and c. And what I mean by that, like in terms of, what I mean by that is I'm going to have something like this. So i.e. x is going to be equal to some kind of formula, and the only variables in this formula are going to be a, b, and c. That's what I mean by when I say in terms of. And you may have come across this type of terminology in the past. Like if you might be asked on a question to say, oh, express this in terms of x, like express y in terms of x. That means that the only variable that you should see is, in that case, x. So we're going to solve for x this time in terms of a, b, and c. So at the end of the day, when we finish this formula, I want to say that x is equal to something, something, something with a, b, and c. And that's what the quadratic formula is. It's a formula that only has a, b, and c as variables. Which makes sense, right? Because those are the only variables in this quadratic equation, ax squared plus bx plus c, right? So hopefully the formula doesn't, require you to know something about d, right? Because we don't even know what d is. Like I just made that letter up. So yeah, so that's what the quadratic formula is. Okay, so let's start deriving it. So I'm going to write derivation of the quadratic formula. Okay, so we're going to derive the quadratic formula, and really all we have to do is just complete the square like we were doing already. The only difference is instead of having numbers, we are going to have letters. So it's the same thing. It's the exact same thing. So It does take a little bit of time, so we do have to be patient. It'll probably take us a good 5 minutes to just write down all the steps, but we'll do it anyways. So we start off with ax squared plus bx plus c, and that's all equal to 0. Okay, so just like before, what we're going to do is we are going to divide both sides of the equation by a. So essentially what I'll do is I'll factor out an a. So I'm going to factor out an a, and I'll get x squared plus b over a times x plus c over a, and that's all equal to 0. And then I'm going to multiply both sides of the equation by 1 over a, 1 over a, and then these will cancel out, and this will also cancel out because 0 times anything is 0. So on the right here, we still get that this is equal to 0, but on the left, we get just, well, now we don't even need the brackets. We just have, we have x squared plus b over a x plus c over a. Okay, so I know I'm going really fast, but I just want to get the first few steps out of the way, because I want to point something out here. Now you might, like, if you're sort of the mathematical police, you might say, stop, hold up, what if a is equal to 0? I just divided by a, and a could be anything, right? A is a variable. We don't know what a is. What if a is equal to 0? And what if I just did 0 divided by 0? Or in other words, 0 multiplied by 1 over 0. That's like a huge no-no. Well, a is not 0 here. Otherwise, ax squared plus bx plus c would not be a quadratic, right? Because if a was 0, then this would be 0. The ax squared would be 0, and that would just be 0. So we would actually have a linear equation. It would just be bx plus c. So we can gladly divide by 0 without any worry about what it means in terms of dividing by 0, because it's not 0. We know it's not 0. If it was 0, then this wouldn't be a quadratic equation. It would be something else. So we have assumed this is a quadratic equation, and that means that this a is non-zero. If it was 0, then it wouldn't be a quadratic equation. So don't worry. We're not breaking any mathematical laws. I know that a lot of you will sleep much better tonight knowing that we didn't break any rules in our math class today. So let's go back to the equation at hand. So we've got x squared plus b over ax plus c over a. And what we're going to do is we're going to complete the square. And I just want to make it very clear which sort of terms I'm looking at. So I'm gonna change the color to let's actually do yellow. So I'm gonna complete the square, which means that I'm gonna take this yellow bit and I'm going to sort of change it. So I'm gonna have x squared plus b over ax, and now I want to complete the square. So on the side here, I'm gonna have b over a, and I'm going to multiply it by a half, or in other words, divide it by 2. So I've got times 1/2, and then I'm going to square it, which gives me b over 2a squared, which is b squared over 4a squared. Okay, so that's what I'm going to add and subtract. B squared over 4a squared. So I'm going to add b squared over 4a squared, and I'm going to subtract exactly the same thing. So minus b squared over 4a squared, and then I'm going to go back to green because that's what's left over. Oops, I still have the c over a, so plus c over a, and that's all equal to 0. So you'll notice the only thing that I did here is I added and subtracted this b squared over 4a squared. So I haven't actually changed the equation, but you'll notice that this portion here, now I'll turn to pink. So now this portion is a perfect square. This portion in pink is equal to x plus b over 2a squared. And if you don't believe me, you can expand that out yourself. If you're wondering where I got the b over 2a, that's what's inside these brackets, this b over 2a. So if you're wondering, okay, how did Mr. Bennett get this? Well, that's inside here. So if we wanted to expand this, we would get exactly the same thing that's over here. Okay? Now, going back to yellow, I'm going to sort of complete that portion right there. So I've got b squared over 4a squared. So I'll write b squared over 4a squared. And I'm going to write this c over a. That's in green right now. I'm going to write that over the denominator of 4a squared. So basically, I'm going to find a common denominator. So I'm going to say, okay, well, in order to turn that into 4a squared, I have to multiply it by 4a on the top and bottom. So I've got 4ac over 4a squared. That's all equal to 0. And let's just clean that up a little bit. So I've got x plus b over 2a squared minus, well, I'll write b squared plus 4ac all over 4a squared, and that's all equal to 0. Okay? Now let's bring this over all to the other side. So in other words, we're going to get, so now I've just got x plus b over 2a squared. That's all equal to b squared plus 4ac all over 4a squared. Okay? Oh boy, this is it's a lot of work, isn't it, deriving the quadratic formula? But it's really just the same thing that we've been doing. We're just completing the square. The only thing is that none of this simplifies into a nice, cute little fraction. We have to carry every single variable with us wherever we go. So it's kind of like an uncompressed sort of formula, right? We're keeping everything in its original state. We're not sort of compressing it down to a simplified fraction. Okay, on the top of the fraction, shouldn't it be b squared minus 4ac? Good question. I think you might be right. Yeah, I think it should be b squared minus 4ac, but I'm not sure where I went wrong. Otherwise, the discriminant would always be positive. Oh, yeah. I know what I did wrong. Yeah, this should be, sorry, plus negative there. There we go. So now what I'm going to do, I'm actually going to subtract both sides, which gives me a negative here. Yeah, my bad. Yeah, that was looking a little bit funny. It should definitely be b squared minus 4ac. There we go. Thank you, Weldon. Didn't notice that. Okay, so there's where we stand right now. I just had a little misunderstanding with a negative there. So make sure that your notes reflect that. Okay, so now what we're going to do is we're going to take a nice little square root of both sides. So we'll take the square root of this and the square root of that. These square roots will cancel, and we have to be careful when we take a square root. Whenever you introduce your own square root into a problem to get rid of a exponent of 2, you have to keep in mind that the inside of these brackets could have been positive or negative, and you would have just got a positive anyways, because anything to the power of 2 is going to be positive. So in order to combat that, what we do is we just write a little plus or minus outside of the one of the square root symbols. And that allows us to accommodate for those negative values that may have happened inside the brackets here. So in other words, what we get is x plus b over 2a equals plus or minus the square root of, and I'm going to make a nice big square root here. I've got b squared minus 4ac all over 4a squared. Beautiful. Okay. How are we doing here? Okay. So there's two more steps that I want to do. The first one is I want to sort of take a look at simplifying this radical right here. So we're going to simplify this radical, okay? And we haven't really done too much work with radicals this year, but I'll just give you a quick fact. And the fact is that if I have the square root of a fraction like this, then this is equal to the square root of the top divided by the square root of the bottom. So we're going to split up that square root. So we're going to have x plus b over 2a. That's equal to plus or minus the square root of b squared minus 4ac all over the square root of 4a squared. Okay? And you might notice that in the bottom here, this is a perfect square. So we can actually take that square root. So we have x plus b over 2a is equal to plus or minus. I'm going to just move this down a wee bit. I'm running out of room. There we go. Plus or minus the square root of b squared minus 4ac all over 2a. And that's really convenient because we have a 2a over here and a 2a over here. So when I inevitably move this to the other side, when I move that to the other side, so when this comes over here, these are going to have a common denominator of 2a. So it'll actually work out quite nicely for us. So moving right along, I'm going to go ahead and do that. So I'm going to bring this negative b over 2a to the other side. So I have x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And x is equal to, well, let's just combine those common factors, or so those common denominators. So I'm going to have negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'll put that in a different color just to signify that we're done. We've solved for x. X is completely on its own. So now we know what x is equal to in terms of a, b, and c, just like we wanted to do, right? We solve for x in terms of a, b, and c. So that's the quadratic formula. And I'd really like it if you could take a little bit of time to try and memorize this formula. And I know that memorizing is kind of a pain in the butt and it's kind of annoying, and it doesn't really help with your deep understanding of it, but sometimes just memorizing things makes your life easier. So I think it's worth it to memorize this formula. If you want, you can also memorize how to derive the formula. It doesn't take too long, but it is a good exercise to be able to do it yourself. But in any case, we're going to be using the quadratic formula enough that it's going to be worthwhile to know how to use it without having to derive it. To just have that right in the back of your head. So if you ever need to quickly solve for a quadratic, you can boom, just pull out the quadratic formula and solve for x immediately. So let's quickly just use the quadratic formula just to make sure that it actually does work. and then we'll verify our solution using Desmos. So I'm going to just quickly pull a question out of this textbook. So let's do this question here. Yeah, let's do this one here. So we're going to do e.g. use the quadratic formula, the QF, to solve. Or actually, let's use some of the new terminology to calculate the roots of 6x squared minus 14x plus 8. Okay, so we're going to use the quadratic formula to calculate the roots of this degree 2 polynomial, or this quadratic expression. Okay, so I learned the quadratic formula when I was in, I think I was in grade 12 when I learned it. That was a long time ago. That was over a decade ago, and I still have it memorized. I mean, keep in mind, that's not the last time I used it. There's a question in the chat. So is this supposed to be equal to 0? Well, we don't have to have this set equal to 0. If I'm looking for the roots of this polynomial, this polynomial doesn't have to be an equation. We're just looking for the roots. Oops, I was supposed to underline that. We're just looking for the roots. So the roots mean the solution to the equation where we set this equal to 0. So, that's a good observation. But we don't actually have to have this as an equation if we're just looking for the roots. The roots mean, okay, what does x have to equal in order to make this equation be 0? So when we're asking for the roots, we're not necessarily given an equation. We're just given a polynomial expression. So, but excellent question. So let's identify our a, b, and c. So a here is equal to 6, b is equal to negative 14, and c is equal to 8. So there is our, those are the variables that we're going to use, and x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so if you can memorize that, then you're golden. All you have to do is just start plugging in the variables. So this is equal to, well, negative b, that's going to be positive 14. So I've got positive 14 plus or minus the square root of b squared. So that's going to be 14, or negative 14 squared, minus 4 times a is 6 and c is 8. Okay, so let me just extend that square root a little bit. And the denominator is 2 times 6, and that's obviously going to be 12. So let's start simplifying this a little bit. So I've got 14 plus or minus the square root of 14 squared. What's that? I want to say 196, but I want to be sure. Let me just double check here. I don't actually have a calculator with me. I left all my calculators at work. So 14, okay. You know what? Let's just do it the long way. So 14 times 14 is, so 4 times 4 is 16. 4 times 1 is 4, 5, and then 14. Yeah, it was 196. I just wanted to be sure. So I've got 196 minus 4 times 6 is 24, and then 24 times 8. So let's quickly do that. 24 times 8. So 8 times 4 is 32. 8 times 2 is 16. Plus 3 is 19. So I've got 196 minus 192. Okay. and that's all over 12. Okay, so let's keep simplifying that, and we'll get this is equal to 14 plus or minus, well, 196 minus 192 is 4, so I've got plus or minus, the square root of 4, which is 2, all over 12. So this is going to be equal to two things. So this is equal to, well, if we add, so that plus or minus means that on the one hand we're going to add, and on the other hand we're going to subtract. So let's do that in two colors. How about, let's say that in blue we'll add, and in pink we'll subtract. So when we add, we have 14 plus 2 all over 12. So that's equal to 16 over 12. Both of those are divisible by 4, so that is 4/3. And then in pink, we're going to subtract. So I've got 14 minus 2 over 12, and that's equal to 12 over 12, which is equal to 1. So those are the roots of my polynomial. Cool. Let's quickly head over to Desmos and see what we get. Let's see if we get 4/3 and 1 as our roots. So 4/3, if you don't remember, is approximately equal to 1.33. So we should get around 1.33 and 1 as our roots. So what do we have? 6, -14, and 8. So let's go over here. I've got 6x squared minus 8x. X. What was it? 6, 18, and 12? No, 6, -14, and 8. Boy. 6, -14, and 8. So just let that sink in. You know, your math teacher can memorize the quadratic formula quite easily, but when it comes to 3 numbers, he's completely helpless. So maybe that's a signal that maybe the quadratic formula isn't that bad to memorize, right? If I'll say it's easier to memorize than 3 random integers. Okay, so look at that. Those are the roots of our polynomial. Isn't that beautiful? So we have 1 and 1.33 repeating, or in other words, 4/3. So that's fantastic. That makes me really happy. Okay, I'm wondering how much time we have left. You know what? We've been going for about 45 minutes. That's a long time for me just to be talking and talking and talking and talking. So what I'm going to do is I'm going to make a little worksheet for us, and I'll put it on the website shortly, and we'll kind of call it a day. And tomorrow, what we're going to look at is a little thing called the discriminant. And the discriminant is basically just what's going on underneath the square root symbol. So it turns out that this little thing right here that I'm changing colors to, let's say, purple, this thing right here ends up being quite important. What's happening with the b squared minus 4ac. That ends up having a huge effect on the roots. So is this formula also used to determine how many roots the polynomial has? Yes, absolutely. That's exactly what I'm talking about right now with the discriminant. So this little part, the b squared minus 4ac, that tells you exactly how many roots you will have. And that's what we're going to talk about tomorrow. So for now, what I'm going to do is I'm going to post just a few questions on the website just so you can have some practice with this. Also, I want to let you know just a little something that I've figured out. So I've figured out that there's this program called CrowdMark, and this is how I'm going to start doing assignments while we're working from home. So I haven't got your all of your information punched into the website yet, but that's my goal for today, is to have everyone sort of enrolled in CrowdMark. I've never used it before, but I think it's going to be interesting. Apparently, I can mark it right on my iPad and then send you your results immediately. So hopefully it'll work out for us. But I just wanted to give you kind of a sneak preview of how we're going to be doing assessments and marking and assignments and that kind of thing. I've heard of some people using this for tests. I'm not really sure if that's something I'm going to do yet. I'll probably just stick to assignments for the time being. But in any case, I'm actually quite excited about what this means for us, because we're going to actually be able to just continue on, and I'll be able to give you feedback and everything, because these YouTube videos are great. But there's only so much that I can do when there's only one direction, right? Like right now it's only me talking to you. There's a few people in the chat. I get a couple emails every day. But you compare that to our classroom, where I'm constantly circulating, and we have work periods, and we go to the whiteboards and we talk to each other. Right now there's none of that. So I'm really excited about trying out this CrowdMark program. Hopefully that'll be a really good way for you to get some more feedback. It would also be nice to have some more assignments where maybe we can try to work together, and you can help each other out. So yeah, I'm really looking forward to that. Another thing too that I'd like to maybe just throw out there to see if anyone is interested. With my AP Calculus class, they have asked me to use Discord. So I'm wondering if you guys would like that too. The cool thing about using Discord is that there is an audio feature. So that means that if you have any kind of like microphone on your either computer or your phone, anything like that, then you can use that microphone to talk to me while I'm going live, which is actually, it works a lot better than I was expecting. Also, the lag is much less than YouTube, and I can also stream to both platforms at the same time. So I can stream to Discord and YouTube at the same time. So all of the benefits of YouTube about having everything sort of be archived as soon as it's over, all of that still remains in place. The only difference is that now I'm also streaming to Discord as well. So I'll put a little note on the website about Discord. And if you would like to use Discord, let me know. Either make like a YouTube comment, or send me an email or an Instagram message, anything like that, and I'll take that into consideration. It would be nice if you guys can just talk to me live, and I think that makes it a little more interactive. Because sometimes you ask a question in the YouTube chat, and I might miss it. Or something like that. So just some things to keep in mind. So yeah, stay tuned for the homework, and hopefully by tomorrow I'll have this CrowdMark thing figured out, and we'll be able to continue on with that. And anyways, I hope that everyone is doing okay and staying safe and healthy. Just a couple of things that don't really have anything to do with math, but just so you know, like this isn't my first time working from home. I've had quite a few jobs where like I'm making a website or something, and I end up just working from home. So I've done this quite a few times. I mean, nothing quite as severe as this, but something that I've noticed that I struggle with when I'm working from home, and this might be your first time working from home, is just little things like with your schedule. Like usually, like my reminder for myself when I brush my teeth, I do that. It's like the last thing I do when I leave the house. So if I'm not leaving the house, I don't have that same reminder to brush my teeth or to shower and take care of my personal hygiene. So so whenever I work from home, I have to sort of set little reminders for myself to take care of yourself, and it's really important to do that. So if you haven't brushed your teeth yet today, maybe do that after the live stream now. If you haven't showered, go ahead and do that. Try to find a spot in your day where you do these things, because often school is great for that because, you got to get there before 9 a.m. and you usually, you might wake up at 7:30 or 8 and there's kind of a scramble to get all that stuff done and out of the way. But if you're staying from home, you don't have those same reminders. So remember to take care of yourself. Make sure that you're staying clean and healthy. You're having breakfast every day. If you can, try to do just a little bit of exercise, even if it's just walking around your house. Like, you don't have to, do jumping jacks or anything, but it's probably a good idea to, take a bit of time away from the computer and kind of stretch your arms a little bit. Maybe walk to your kitchen and do like a little lap around your house. Just do your best to take care of yourself and make sure that you're as happy as you can be, because we're all stuck inside and honestly it's a bit of a drag. So anything that you can do to make your life just a little bit more normal, I think you should do your best to try to do that. Anyway, I'm going to sign out, so stay tuned for some homework and some assignments, and I'll put a little note about Discord on the website. So take care, and I guess you guys will see me tomorrow. Bye-bye.